Record. Okay, cool. All right, so this is our first review session. Thanks for coming. Okay, and those of you who can't be with us today, take a look at this when you get the chance, and hopefully it answers some of the questions before you have a chance to ask them. I'm going to take care of a few topics today. The ones today I'm going to take care of are the ones that I have been asked about, as I have desperately requested people do. We're going to first talk about production possibility curves back from Unit 1. Then had a question about the labor force that was taken care of in Unit 2. And then we're going to talk about aggregate demand, aggregate supply, and how it relates to long run aggregate supply in Unit 3. And then also include something from, it's really kind of Unit 4, Unit 5 mashed together. How does that monetary policy type stuff affect what's going to happen to the long run aggregate supply, price level, output, and so on, and see if it has any impact on long run aggregate supply. Okay, so let's just go ahead and jump right in and first start with production possibility curve, since that's like the longest time ago. Let's start with that. Remember, production possibility curve deals with opportunity costs, comparing two items. And we have to remember that we are only looking at two items because we're looking at the two choices, the two best choices with the resources that we have. Okay, so we can graph this. So the production possibilities curve is a graph. Right, so the graph will be a very simple or basic graph where we have an item over here and an item over here, and we have a limited number of resources and technology and so on to choose from. And as a result, there is a limit to the combinations that we can have of this. Okay, and there are two different curves associated with this. Sorry, it's the same curve. It can look in two different ways. One can be bent, or the other one can be correct, straight. Okay, they represent different things as far as the resources are concerned, but it still helps us to answer the same question, which is what combinations are best for us to create, right? When it's a straight line like this, the slope is constant. It means that we are giving up our resources in equal amounts to get equal amounts as we proceed, meaning if I want to improve by, if I'm here and I have producing 5y and 10 of x, okay. If I want to make and get 11x, I have to give up a certain amount of y, okay. And maybe I have to give up 2y to get one more x, okay. But if we do it the other direction, 9, it should be the same exchange rate, if you will. We still have to give up the same amount, right? Because it's a constant slope. So if I'm going to want to produce 2 more y, I'm going to have to give up 1x. Okay, so here we're looking at a ratio of 2 to 1, 2 y's to 1x. And that will be the same everywhere on this line. That's why it's straight. Okay, or if it's bent, the bent represents the idea that we're not exchanging resources consistently between item X and item Y. We're giving up more at some points than at others. This is a bit more realistic for most of the things that we have in production. But we use this one when we were using and doing the example of using time, where we did time for schoolwork versus leisure time, and an hour is an hour is an hour. Okay, if I give up 1 hour of leisure time, I'm gaining 1 hour of study time. Right here, we're looking at how resources are used and how they will be exchanged. And to use, let's say, some of the same numbers, I want to use 5, 7, 9, 3. Okay, let's say 5 here is 10 here, right? That's the same starting point we had before. If I want to produce 11 over here, I might have to give up even more, because the slope here, let me get a different color for this. The slope at this point, right between this point and this point, is a different slope than if we went in the other direction. So I might be able to go from a combination of 11x and 2y. Here I've got 10x and 5y, And then over here, I would have 9x and 7y. So the slope is changing as we move along this curve. So here, from this point to this point, we have a different slope. And so the exchange rate is going to be different. Here, for go from 9x to 10x, to increase x by 1 here, I have to give up 2y. But to go from 10x to 11x, I have to give up 3y. So the opportunity cost is increasing as I move along the curve. And even if I go in the other direction, okay, and I were to go and make these even intervals 2, 3, 4, 5, 6, 7, 8, 9, right, I would have to give up an increasing amount of x's for every 1 y I want to increase over here. And so that's why that is bent, right? And that's what the production possibilities curve represents, right? The other thing about the production possibilities curve that is actually interesting and comes back in later units is how this line itself, right, whether it's bent or straight, represents the maximum efficiency, right? And we talked about that. We said if we're at point A, we're at maximum efficiency, we're not wasting resources, we've got all our resources being utilized, the technology is being utilized to its fullest capacity based on what we have, right? If we're at a point like point B, right, then we're wasting resources. There's, maybe factories that aren't being used, there are workers who are unemployed, right? But there we have capacity, we have the potential to be out here, but we're not using it all. Okay. Or if there's a point, let's say like point C, that's outside the curve, we can't get there just yet. We don't have the technology, we don't have the resources, we don't have the manpower to actually get out to that curve. And so the goal, of course, for any society is to find new and better ways to produce so that we can move this curve outward, so that eventually we'll be at C. Because a long time ago, B was the maximum efficiency, or one of the combinations of maximum efficiency on this line. But we've grown in population, we've improved our technology, right? When you think about making copies of something, if I wanted to make multiple copies of a handout before we had, computers with word processors and printers and copy machines, I literally would have to type out 30 copies of the same thing. Now I can give you 30 copies by only typing it out once and pressing a button, and now I've got 30 copies. So this used to be maximum efficiency, right? But now I can get this much. I could still do it this way if I want, right? But that seems like a huge waste of time to type it out 30 times and print it and literally on the paper with an old-fashioned typewriter. Okay, so it matches that there. Correlate that to aggregate demand, aggregate supply, and the long run aggregate supply, right? Full employment and so on. If we can graph this over here, where we got price level and real GDP, we've got aggregate supply in the short run, we've got aggregate demand, and then we have long run aggregate supply. This long run aggregate supply is at full employment. This full employment represents that line on the production possibilities curve. This tells us we are not wasting any resources, we are at full employment. This tells us that we are at full employment. So whatever we can do back in unit 1 that could get this to increase is the same thing that we would be able to do to get this to increase. Okay, does that make sense? All right, so making that connection. So hopefully that answers your question about the production possibilities curve and what it represents. Remember, it's representing opportunity cost. What do you have to give up in terms, in this case, of Y in order to get more X's? Or do it the other way, to get more Y's, what do you have to give up in terms of X? Whatever you put on these axes. If it is school, leisure, if it is, I don't know, using paper to make books versus magazines, right? The choice you make, and the second best option is the other axis. Remember, if you had, as I like to call him, Mr. Magoo trying to go to the football game, try and decide what he would have done in the 4 hours he would have spent if he had gone to the football game. He's weighing his opportunity cost and the value it has to him. Okay. Any questions about production possibilities, Bureau? Let me clear some space here. I don't have anyone waiting to come in.
I do have a question though.
Yes, about this.
About the next module for unit 1, which was comparative advantage and trade. So the math portion, like when you look at a table and you just know like, okay, this one has a better opportunity cost, this one has a better comparative advantage.
All right, that would be best if I was able to pull up a diagram or a table with that data in it already prepared.
Do you want my?
For that, and then I could, make sure to work through the math and make sure I have the right answer.
I was just looking at for the unit 1. Because yeah, that was a
Send me that in advance in the future. Then all right. So we've got this one here from the Everything You Need to Know packet. All right. And we've got Zootopia versus Freshland. Right. It looks like it's coming from the College Board's progress check number 1. Okay. And so we've got 2 countries, Zootopia and Freshland, or Freshland, if you'd rather. And they both make coconuts and mangoes. So they grow coconuts and they grow mangoes. And the question then is, well, we've got a few questions we can ask about this. How much do they both are able to produce either 50 coconuts, or Zootopia can make 60 mangoes, and Freshland can make, or they can make 30 mangoes. Okay. All right, so we have a few questions we can ask here. 1, absolute advantage. Who can make just make more coconuts? Wait, does anyone have an absolute advantage in coconuts?
Well, they make the same.
They both make the same, so no one has, because but neither. They both can make the same amount of coconuts. Absolute advantage. Oh, I should write coconuts. But if they were to produce mangoes, who has the absolute advantage in mangoes? All right, Zootopia, because they can make absolutely more. Okay, mangoes. Now that's neat to know, but that doesn't really help us. What we really need to focus on is the comparative advantage.
Yeah.
Who can make more at a lower cost, right? And that's on a national scale, but if you think about it on an individual scale, that's really how businesses operate, right? They want to be able to produce things, but at the lowest cost. We're not measuring them in terms of dollars here. Instead, we're measuring it in terms of the other item that we have to give up, the opportunity cost, okay, which is related to the production possibilities curve. Okay, so in comparative advantage, if you remember way back, I gave you sort of a how-to on comparative advantage, right? Those pages are just like, these are the steps to follow, how you use it to help work through these types of problems, okay? I don't even remember exactly what page number was in your binder, but it was quite a while ago, right? Because this was unit 1.
Page 12.
Page, what number?
Page 12.
Page 12, excellent. Binder page 12, I'm gonna put that right up here. Excellent, thank you. Right. So comparative advantage, we have to figure out what is their ratio. What do they have to give up to get either coconuts or mangoes? And then from there, we decide whoever can do it the cheapest that's the one they should make. And they should trade to get the other one, right? And if we do this right, we find that one will have a comparative advantage in coconuts and the other will have a comparative advantage in mangoes, right? The question is, how do we do that, right? So we have to look at this ratio. We're going to make a comparative advantage ratios for coconuts, right? We want to know coconuts to mangoes. So if I start with Zootopia, right? Zootopia can do 50 coconuts or they can do 60 mangoes. Okay. If they're doing that on their own, they're probably doing some combination of fewer coconuts and fewer mangoes somewhere on the production possibility curve, right? But if they're doing all or nothing, it's either all coconuts, 50, or all mangoes, 60. And Freshland can do 50 coconuts or 30 mangoes if they're doing all or nothing, right? So let's figure this out. We got 50C to 60M. If I solve for C, right, 1C would be the equivalent of 6/5. I'm just going to keep it as a fraction this time. Okay? Otherwise, it'd be 1.2. We can do that if you want also. But we'll do 6/5 mangoes. Let's flip it the other way. I do 60 mangoes and 50 coconuts. If I solve for one mango, that would be 5/6 coconuts. The nice thing to remember is when we solve one for the other, it's just the reciprocal. If we're keeping it as a fraction, we just flip the fraction over, right? And that is Zealands going on there. Okay, Freshland, right? Similar, but different. 50 coconuts to 60 mangoes, which is one coconut to, 30 mangoes, which is going to be 3/5 mango, right? 30 over 50, yep. Or 3 mangoes and 50 coconuts. One mango would be 5/3 coconuts, right? So now we have to see, we've got one coconut, one mango, one coconut, one mango, and this is what they have to give up in order to get it. Okay, so when it comes to coconuts, who gives up the least to make it? That is to say, who has the smaller fraction? Freshland does, right? Because to make one coconut, they have to give up 3/5 of a mango. That's less expensive than having to give up 6/5 of a mango. In fact, this looks like it's twice as expensive. 6/5 is twice as much as 3/5, right? Mm-hmm. So if we're going to specialize in what we do best, what costs us the least, when it comes to coconuts, you say Freshland should do coconuts because they have the lower price in terms of mangoes, mm-hmm. right? Let's just check our work, because I said before, if one is able to specialize in coconuts, then the other one should have a lower opportunity cost to do mangoes. So let's see if it works out that way. Okay, one mango is 5/6 of a coconut for Zealand, and one mango is 5/3 of a coconut for Freshland. Those are not convenient numbers to work with, are they? But if they were a decimal, they would be, right? Probably be a little loose. So let's see, 5/6, 5/6. 1/6 is half of a third. A third is 36, so 16. So one, we're looking at 0.833 coconuts. And over here, 5/3, that's a little easier. Okay, that's going to be 1 2/3, right? 3/3 and 2/3 left over. So 1.67 coconuts. Oh, that's easier to see which one is smaller, right? And that is Zealand. So in this case, Zealand should specialize in mangoes, All right. So the rule I said before, when one specializes in coconuts, the other one's going to specialize in mangoes. They're going to have a lower opportunity cost, one or the other.
Will there ever be like how you had absolute advantage where it was like neither or like both? Will you ever have that for comparative? Like,
Only if it works out when we reduce it, that it comes out the same.
Okay.
So if this said 50 and 60, and this said 25 and 30, it's the same ratio,
Yeah.
okay? Or 100 and 120, in which case neither would have a comparative advantage.
And when they put that on the exam.
They would not put that on. Okay, because then that would forego all the rest of the concepts they want to see if you understand.
Yeah.
Right? So it would throw out the whole rest of any question they would ask. So did that answer your question? All right, good. So we know now how to calculate that there. And if I'm correct, and I might not be, there might be a question later on that asks that same thing. In the sample long run free response questions, question number 2 has a similar one there. Just be careful in that one. It gives you, right, a graph. It's asking you to graph the production possibilities curve there. Sure, I'm missing here. I'm not even sure if it's asking you opportunity costs or the comparative advantage. But if you're given one that has a whole table, you only need the endpoints. Okay, so right when it comes to well, this is just one country, then this doesn't even line up. But if it had 2 different countries, you would only say this country can make either 100 movies or 80 computers. The other, they would have another table for a different country that they want to compare it to, and it would have its set up for movies and computers. You only need the endpoints, the ones that are lined up with the zeros. Okay. But I'm guessing that the AP exam is only going to give you a table like the one here, which is really the endpoints, because we said Zootopia can make 50 coconuts and 0 mangoes, or 60 mangoes and 0 coconuts. Freshland can make 50 coconuts and 0 mangoes, or 30 mangoes and 0 coconuts.
When the table has the production possibility table has like 2 of the same, like, but they both have a meeting of 2,000, 2,500.
Yep, ignore it.
Or is that, okay, right.
Right, you're saying that on that problem there, the one with Veggieland and Fruitland, Veggieland and Fruitland, you're saying that like point E for Veggieland, it says 2,000, 2,000, or point V for Fruitland, says 3,000 and 3,000. It just is a coincidence.
Okay.
Okay.
So there's no
All you're worried about is for Veggieland, point A. They can make 1,000 artichokes,
or 2,500.
or point F, they can make 2,500 bananas.
Okay,
And for Fruitland, 5,000 artichokes or 7,500 bananas,
okay.
right? And all the rest in between is really just a distractor.
Okay.
Now, they might ask you to move from, if they were to increase their production from point C to point D in Veggieland, how many, in order to make 500 more bananas, how many artichokes would they have to give up? And that would be 2,000. Or what would be the opportunity cost to produce 500 more bananas in Veggieland from point C to point D? Just to throw, the different wording that you can see for that question. You're welcome. All right. So we're good on this for now?
Mhm.
All right. Make some space. And I'm also going to put a different black marker because this one seems to be dying on us a little bit. And the other indicator is that it doesn't erase as well. So it's time to replace it. All right. So I'm going to move on to calculating that labor force. We talked about labor force when we were talking about unemployment. So let me get another one. we won't use black then. We'll use a different color. Like, how about blue? All right. So we talked about the labor force before. We were looking at unemployment, and that's really the only time we're really going to focus on the labor force. We're trying to figure out if they're asking us to figure out, labor force participation rate. Okay. Participation rate. And we would need that in order to figure out, in part, the unemployment rate, because we need to know the labor force in that, and conveniently, in honors econ, that's what we're working on this week. So I got a paper right here. The labor force participation rate is equal to the labor force divided by the eligible population. Population that is 16 years old and older, that's not institutionalized. Other one is lacking as well. So to be part of the labor force, okay, so we need to know who's that? Who's in the labor force? Okay. So the labor force is anyone who is 16 years old or older, okay, who is not institutionalized, which means not in prison or jail, and not in a mental health facility. Okay. So need that, and you have to be looking for work. Looking for work or employed. So if you have a job, then clearly you're in the labor force. If you're looking for a job, you're considered part of the labor force, right? But if you, in order to be eligible to work, you have to be 16 years old or older and not committed to a facility that bars you from working. Okay, even though in prison, right, prisons do have labor in the prison. You've got people working in the laundry, you got people working, sometimes they take them out and they're cleaning doing cleanup on the highways and stuff like that. They're not considered part of the labor force because they're actually don't have much of a choice, right? They do get paid, but they don't get paid minimum wage. It's a whole nother subset that is not included in this. Okay. All right, so that's how we calculate the labor force. And so the unemployment rate. And if you look at the everything you need to know page that I gave you today for unit 2, right? We've got the different types of unemployment on there to refresh your memory, right? And the unemployment rate, you are is equal to the number of people unemployed divided by the labor force. By the way, I need to put it over here also, times 100 because it is a rate. Rate means it's a percent. Okay, and so I need to put the other one times 100 also because it is a rate. Otherwise, you're going to get a decimal. So we got to convert that into a percent. So labor force, there you go. Right. And it does raise the questions of how do we incentivize people to join the labor force, or people who choose to not be in the labor force, right? There are people who are just not looking for work, right? And, you know, different countries have different policies, and different states have different policies too with regard to unemployment. And some places are more generous with their unemployment benefits than others. And places that are more generous with unemployment benefits tend to find more people are willing to not work, or at least temporarily not work, because they're getting paid or getting benefits for not working, right? Or if the benefits are too high, then that would allow people more time to look for work. Okay, so we want to try and find ways to get people, incentivize people to work. And it's not because, the government is wanting to be cruel to people and make them work until they die or something crazy like that. But no, for a macroeconomy sense, the more people you have in the workforce, the more people you have employed, the greater the output would be. In which case, if we can find ways to encourage more people to join the workforce, go back to unit 1, and our production possibilities curve will move outward. Go to the aggregate demand, aggregate supply, the long run aggregate supply, the full employment point of GDP will move to the right because we'll have more resources, that resource being labor. Does that make sense? I know I saw it too. I think it got on the screen too, so he just wanted to be involved. Okay. Any questions? No? We go with labor force? All right. Let's keep rolling then. Good deal. Stuff, so I also see which markers I need to replace. Purple seems to be good. We'll go purple. And now, aggregate demand and aggregate supply, and then monetary policy with that impacts on the short run and impact on the long run. Hope you got some time this day. This is going to be long. All right. Okay, now we're here till 5. So let's see what we get here. So let's draw this aggregate demand, aggregate supply curve. The y-axis is not price, but price level, which is representative of the rate of inflation. Okay. The higher the price level, the greater the increase, the greater the inflation rate is, right? When the price level comes down, we still have inflation, but it's a lower rate of inflation. So from year 1 to year 2, we might have 5% inflation. So inflation's at 5%. From year 2 to year 3, we might still have more inflation, but it might only be at 3%. So even though we have inflation, it's inflation, but just not as fast as in the year before. Okay. And over here, we'll have real GDP, or as I like to put it, GDPR. Okay. So we looked at the aggregate supply curve and we saw different ways of drawing it, right? And different sources that we've used, drawn it in different ways. Some have drawn it just as a straight diagonal line, which really mostly represents the intermediate section, okay, of the aggregate supply curve. We know that we've been talking about 3 different sections: a horizontal section, an intermediate section, and a vertical section, okay, which is best represented in the long curve, right? A very exaggerated straight up and down vertical and a very exaggerated horizontal. We can also do something that's a little bit less exaggerated and just use this simple curve here. And so short run aggregate supply. And remember, this is one of the key graphs that we need to make sure we know the mechanics of. This is going to be on the AP exam. There's no way about it. In fact, most of everything we do in some way has been building to this moment, okay, to this graph. Short run aggregate supply. Even when we talked about individual supply and demand, okay, the combination of all the demands for all the different things is what makes up the aggregate demand, okay? And the sum of all the supplies of all the different things makes up the short run aggregate supply. Okay? So even all of that has been coming to this. We've also looked at using the mechanics of moving things, just the individual demand or the individual supply left and right, and how the mechanics of that is similar to the mechanics of moving aggregate demand and aggregate supply to the left and right. We just have to remember that it represents something different than the demand and supply for an individual product. Okay. And then we can't forget, we have to have long run aggregate supply. And this is a change from years ago. Years ago, there were only sometimes did you need to include the long run aggregate supply curve, but now it seems the best thing to do is include it all the time, right? And you're welcome, when you're drawing your graphs, you're welcome to label, of course, you must label short run aggregate supply, long run aggregate supply, aggregate demand. But this point right here, you can label any number of ways. We've seen it many ways in class. There is FE for full employment level of output or full employment level of real GDP. Some places have labeled it as Y star. Okay. We know it's confusing to put Y on the X axis, but I didn't come up with it, somebody else did. All right. So there we have the basic graph, the starting point. And I conveniently put it all in one place. We are at equilibrium, right? All the lines are meeting together. That is where ideally the economy wants to be, right? And if it's not, if we give it enough time, it will return back to that. But the problem is, do we have the patience for that? If you're somebody, if we're in a recession, if aggregate demand is intersecting short run aggregate supply out to the left, we're in a recession. If we're out here and our output is below the full employment, right? That means not enough goods are being produced to meet everybody's needs and wants. There are people who are not working because we don't need as many workers if we're not producing as many things. So unemployment is higher, right? Can our society, can our government, in a political sense with elections and so on, can those politicians afford to wait this out and let it come back on its own, right? If this is, really just a tiny bit, if this is really like, oh, we're down 0.01%, they can wait out 0.01%, see what happens next. If next comes to 0.01% becomes 0.5%, then maybe they start getting concerned. When it becomes a total of 5% less, then they really need to pay attention and start doing something. But if it's just a tiny bit, let's say that's within the margin of error, okay? And they'll just wait it out. But the bigger this is, the further to the left, the more active a role has to be taken to fix this, because we can't wait. It could get worse before it gets better, like the Great Depression. And the same is true if it's in the other direction. See how good my green marker is. Okay, so if aggregates of demand and aggregate supply intersect over here, okay, then we're experiencing higher rates of inflation. Can we wait out higher rates of inflation? Or does the government need to do something to intervene? Right now, our economy is experiencing higher rates of inflation. The Federal Reserve is doing what it can to slow that down. Okay. The things that we're literally learning about right now are things that are literally happening in real time right now. So it's not just theory, it's reality. The numbers that they're using, we use in class and they use in reality may not be the same, because like we saw in the video today, we make the assumption in the class that when they do monetary policy, that all of the money that is excess reserves will be loaned, and the banks won't hold on to any excess reserves. And then we assume that all the money that is borrowed is going to be spent and deposited in another bank, which would then have the reserve requirement, and then what's left over, the excess reserves, would all be loaned out. In reality, banks keep some excess reserves. In reality, not all of the money that's loaned out gets spent, right? So it's not going to be like we are looking at what is the full effect when the change happens. But in reality, it's not as simple as that. Okay. All right. So the government's going to try and combat the higher rate of inflation or the higher rate of unemployment and try and get us back here. You can wait it out, but can we? Do we have the time, the patience? Can we afford it to become like another Great Depression before it starts to rebound? Or do we have to take an active role? So those are the curves themselves, okay? And what it means. Notice I did not move aggregate supply, okay? Shifting aggregate supply is trickier. It is not one of the tools that the federal government, whether it's the Federal Reserve or Congress, has using fiscal policy or monetary policy. They don't have the tools to move aggregate supply. That's not their job, okay? So when aggregate supply moves, it's usually due to something unrelated, something that is beyond their control. They can influence the shifting of aggregate supply, but nothing's a guarantee. They can, subsidize industries to be more fuel efficient or more technology based or something, but that only can influence the aggregate supply curve moving to the right. So the biggest impact they can have is on aggregate demand, and that's what monetary and fiscal policy will do.
AD and AS cannot move at the same time. There will never be a scenario when they move together.
We will only move one at a time.
Yeah.
The reason why they both can move in the same example is like the question you asked me earlier, right? If we are using the green line here and we have inflation, right? In the short run, in the long run, what's going to happen is wages are going to rise because price level is higher. Workers are going to want a higher pay. And that's technically what's happening right now. Okay. And when that happens, that means the employers, the businesses, the factories, all of them together, right, are eventually going to be paying their workers more, which means the cost of their resources, labor is a resource, is higher. They can afford less resources. So if they can afford less resources, then that means the amount of things they can produce decreases.
Mhm.
So in the long run, aggregate supply would then move to the left, and they would then meet up over here at this higher, eventually at that higher price level. But it would come back to full employment.
Question.
Yeah.
Can you go over those names or like cost pool?
Sure.
inflation,
Okay.
And those terms.
Absolutely. So if we're moving aggregate demand, that is not an I. Okay. This is the result of aggregate demand moving to the right past the full employment level. So when aggregate demand increases and people want more and more things, again, like we're seeing right now, in reality, okay, we're driving up the price level because people want to buy more things, but there aren't as many things out there for people to buy. So it's driving up the prices. Okay, increased demand with the same supply, prices go up. And since it's not just the price of, rice or pencils, it's the price of everything. Aggregate, the inflation rate is here. Right? Now, cost push inflation is a result of, let me put all the letters there. Short run aggregate supply moving to the left below full employment. So that's below full employment. And when that happens, again, the intersection, I'll have to draw a different graph for that. And I'll just draw one aggregate demand curve and two short-run aggregate supply curves. So here is our aggregate demand. Here is short-run aggregate supply. Here is long-run aggregate supply. And then we have something that shifts short-run aggregate supply to the left. Okay. There is your increase in the price level. So we went from this happy medium to that one because aggregate supply shifted to the left. Usually that's the result of something outside of our control. It's usually the result of an negative supply shock. Exactly. The problem with this is not that we're just getting a higher rate of inflation. Actually, I drew you the wrong point. It's my apologies. It's actually where aggregate demand and aggregate supply meet, not where they meet long run. My fault. It's not only that we're getting a higher rate of inflation, but we're also getting lower what?
GDP.
Lower GDP. And when we have GDP that's below the full employment, what is this called? We're below full employment.
Oh, it's a recession.
We're in a recession. We have a recessionary gap. Exactly. Okay. So this doesn't just result in a higher price level, but it also has the double whammy. Okay. Recession / unemployment happening. And therefore the dreaded, when you have inflation and unemployment growing, we've got the awful stagflation. Beware stagflation. Boom, boom. And that's the evil guy. And that is unfortunately, in addition to having in real time right now, an increase in aggregate demand, having demand pull inflation, we also have aggregate supply has shifted to the left. We're having a shortage in fuel. Okay, think of the gas prices are going up. Gas prices, at least the gas station I'm driving past every morning, is $4.19. Okay, and it was $3.99 on Monday. And today it's $4.19 and it's Thursday. It was actually $4.19 on Tuesday, right? It jumped 20 cents. Is that because more people are driving? No, same number of people are driving. The supply must have decreased. And what's going on that's going to decrease the supply of energy, of oil right now?
The crisis.
Which one?
Ukraine.
In Ukraine, exactly. So the war is going on. Russia, a large supplier of fossil fuels, and particularly, well, I guess all of them, coal, oil, and natural gas, right? Since where fewer countries are going to be trying to switch away from Russia's supply of fossil fuels, that's going to drive up the demand for other sources of, in this case, oil. So that makes those sources more expensive. And when I go fill up my gas tank, more expensive. And by the way, when Amazon fills up their gas tank, more expensive.
The prices are
When airlines fill up their jet fuel, even though it's not gasoline, it's still derived from crude oil, it's more expensive for them. Right? So all the shipping costs are going to increase. which means all those things are gonna be more expensive to us.
Mm.
Sure, I have Amazon Prime, so my free shipping, right? But maybe they're gonna have to raise the cost of Amazon Prime to cover the free shipping.
Mm.
Is it really free? Right? So that far. But that wasn't the full question you had. You had a question now about what about how does monetary policy come into play here? Right? How does that have to do with interest rates? Right? Okay, let me clear some of this off right here and make some room for that. Excuse me, guys. We'll be back. Better than it. All right, so let's see. Remember where I put my markers. We've got two problems to combat, right? Hopefully not at the same time. Let's combat them one at a time. One would be inflation, the other would be unemployment and recession. Let's hit those. Okay. So if we have recession right on the screen. Okay. Unemployment. What does that graph look like? Let me draw it a little smaller here so I have enough room to add some things. In my short run aggregate supply. My aggregate demand. Let's draw this too big. Here's my long run aggregate supply at full employment. Here's the price level. And there's our output. Okay, so we are in a recession. We know this. If we look at the graph, we know this because the intersection of aggregate demand and aggregate supply is to the left of full employment. Right? So that's how we know we're in a recession when we look at the graph. When they ask you to draw a recession, make sure that your intersection is to the left of long run aggregate supply, that is to the left of full employment. Okay. And I forgot to label my axes, GDP, R, and price level. Right. So in order to fix this, right, the government has two sets of tools to work with: monetary policy, fiscal policy. Either way, we want to have more items being produced. We want expansionary policy. Okay. So if we're looking at monetary policy, they have three options. The most frequently used is open market operations, which was, if we're expanding, if we want the money supply to be, do we want the money supply to be bigger or smaller here? Bigger. So is the Federal Reserve going to buy or sell securities? Buy, B and B. We're going to Fed, I'm going to write it this way. Fed buys securities. That's tool number one. Tool number two is the discount rate. And so instead of buying securities, they could lower the discount rate. Or three, they can lower the reserve ratio or reserve requirement. By buying back securities, that's putting money into the hands of bank customers or putting money into the hands of the banks. Either way, it'll increase the money supply. What does that look like on a graph, you ask? I'm glad you did. Let's draw this graph for the money supply. Okay, we've got the interest rate over here, and we've got the quantity of money on this axis here. The money supply is vertical. It is independent of the interest rate. Okay. Supply of money and the demand for money is dependent on the interest rate, so it has a negative slope. If they do any of these three things, it's going to put more money into circulation, right? This is the original interest rate. We put more money in circulation. It lowers the interest rate. And at lower interest rates, more people will borrow money. Okay, so all of these things will increase the money supply, lower the interest rate. Okay, awesome. So how will that then impact the big picture? How will that get aggregate demand to move to the right? Well, if consumers have more money in their pockets, okay, it could end up making consumer spending increase. And if consumer spending increase, right, then that will result in aggregate demand moving to the right. If this policy encourages more loans, gross investment will increase. That will move aggregate demand to the right. And once it moves aggregate demand to the right, now we're going in the right direction here. And if they get the numbers right over time, because they're going to do this gradually, who knows? Maybe they nail it.
Wait, question. For the investment, you didn't put a nail. You didn't put a-
It should increase. So that would be an expansionary policy. Okay. And then if we're fighting inflation, then they would do the opposite things. But we're going to draw this graph real quick also. And I'm looking at the time and we're almost out. We actually are out of time, which is why I extended my video to 15 minutes more just in case. Otherwise, the call ends. GPR. Okay. And so here is short aggregate supply. Here is aggregate demand. And here, oops, can't fit it in. Long run aggregate supply is in there. Okay. Here's full employment. We're meeting somewhere over here, a little bit to the right, but the price level is way up high. So we're fighting inflation here. We've got to get aggregate demand to move to the left before we decrease aggregate supply, before that happens. Okay. This is crooked, isn't it? It's a bit crooked, but will do. All right. So we want to have a contractionary policy. Right. So if we're doing monetary policy, it will literally be the opposite of what we wrote over there. One, open market operations. That would be, instead of buying securities, they want to shrink the money supply or make it smaller. The Fed sells, S for S, right? Securities, S for smaller. Okay. Or two, they can raise the discount rate. Or three, they can raise the reserve requirement. Those are your three options. When that happens, we can see a decrease in consumer spending because they're taking money out of circulation from borrowing. We will see a decrease in investment, which will also decrease aggregate demand. How does this look on the money graph? Well, it's the exact opposite of that one. And that's one of the nice things about this and the fact that it's theory, is that When we do it in one direction, great. When we want to do the opposite, then we literally do everything in the opposite direction. Okay. So here is the interest rate. Here is the quantity of money. We have the supply of money. Got the demand for money. The original interest rate. We make some of these changes over here, one or more of these, and we decrease the money supply. When we decrease the money supply, we increase the interest rate, right, which gets us these results. And then hopefully, again, if they get it right, we can hope that they get it right. Okay. Any last questions for today, at least? No? All right, cool. I hope this was helpful. It may have stimulated other questions as it digests, and that's fine. Just make sure you send them to me and we'll plan for more. All right.
Because I know I didn't send you. I don't think I have any questions.
And sometimes you don't realize you have a question until you have a
Yeah.
question.
Until later.
So, all right, cool. Hopefully this helped you guys out there too, when you get to watch it later. Ooh.